You see the screen? Yeah.
Yes, sir.
So for fire alarm system, we are going to discuss on different components that you have it. The first is detectors. In detectors, you've got something called as heat detectors and smoke detectors. Again, in smoke, you have two types. One is basically ionization type, and then you've got something called as optical type. In optical, again, you have two types. One is your spot type, and other is beam detector. Yeah. So heat detector is generally your spot type anyway, but we just call it as a heat detector. And along with this, you have got something called as multi-detector. Multi-detector, which is having both smoke and heat capabilities. Understood? So you have smoke, heat, and then you've got one more type, which is your multi-detector, we call it as. So heat detector only finds the heat. It will not worry about smoke at all. So if the temperature rises using a thermostat, it will detect that there's a fire inside the building. There's one more thing, which is smoke, which is a byproduct of heat in most of the cases, right? So in that case, we've got something called as ionization type and optical type. So ionization type we use in very rare applications. I mean, applications where the fumes are transparent, you basically use this type of ionization type of detectors. Generally, 99.9% of the times, you generally use your optical type of detectors only. Okay, so I'll explain you how this, because heat and you not explain much, you just have a simple thermostat, a small temperature sensor. When the temperature reaches a certain point, automatically detect fire and it will signal to the fire alarm system. Understood? But whereas your smoke detectors, I've told you, you have two types. One is your ionization type, and other is optical type. So optical type, generally, it works on this principle. You have a small transmitter. So you've got a transmitter which will continuously transmit your signal like IR radiation. Okay, it will continuously give your IR radiation like remote control. Okay, now you have receivers at certain angles. You've got one receiver here and one receiver. I'm like two, three receivers depends again on the model. These are your receivers. So this is one receiver you have it over here, one receiver you have it here. Generally, I mean, this is all encapsulated in a single one. Don't worry. So this entire thing is encapsulated anyway. Okay. So generally, when you have this guy, your transmitter will continuously transmit, but your receiver will not receive any signal. Okay. But if there is a light or anything, don't you think if you have if you have any particle, dust particle or smoke particle, don't you think it will reflect the light or not?
Yeah.
Yes. So what will
Yes, sir.
happen if there's any particle that is there, if there's any opaque particle, what is going to happen? This particular particle will basically reflect the lights. So when it reflects the lights, automatically it will reflect in all the directions or not?
Yeah. Yes, sir.
So it will even then when it reflects, even receiver will receive it, and once it receives the signal, then it will tell that there's a fire inside the building. Understand? You will MOSFETs and all anyway. But anyway, whenever the basic physics principle is simple, when any dust particle enters into it, it will reflect. Because of that, the receiver will receive that there's a fire inside the building. Clear?
Yes, sir.
That is spot type of detector. This is simple spot type of detector. The general wiring is simple for spot type of detector. If you see the end of the base cap, it will be something like this. If you see a detector, it will have the following components. So it will have four pins generally. Okay, nowadays, the wiring is also slightly changed, but few models are still following this. You have a general resistor between these two elements. Okay, you have a small resistance along this one. Okay. So, generally, how does it work is generally when we have a detector, we multiple components will be provided in a single loop. So you have one cable, which is a two-core cable, which will be connected. In that you have, like, when you say two-core cable, don't you think it's red and black or not? I mean, positive and negative. Yes or no? So in that, generally, you use your both positives, you connect it to a single one, and then again it will go out. Whereas the negative cable, and I'm just showing with the, like, gray color here. The negative will be connected from here to here and again from here to here. So like that, it will go in form of loop. Understood? Yes or no?
Yes, sir.
Yeah. Then along with that, you have one more point that's left that we use it for response indicator. So the next component you're going to learn is response indicator. So this one will be connected to the your positive of your RA will be connected to your response indicator. This one will be connected to a detector, which will be connected to a hardware called as response indicator. Okay. What does this response indicator does is this response indicator will just show the response of the detector. I'll explain you. And negative will be connected either here or here, it's fine. You'll be connecting it negative to this gate. That's it. Okay. So one is positive, one is negative. So basically, what is this response indicator means? Generally, if you see a detector, I'll just open any detector image. Just a second now. Detector. Smoke detector. Sorry. So if you see any detector generally, let's say this is your image. If you could see a LED over here,
Yes, sir.
a small bulb. So you have two LEDs generally, or the same multicolor also they could use it. So generally what will happen is when there is no fire, it will not show any signal at all. It'll just blink in green. That means the system is healthy. Understood? But whereas if it starts blinking in red, which means that there's a fire inside the building, obviously not just that a small red LED will not alert anyone, so it will be single signal to your fire alarm panel also. But you have to know exactly where the fire is by visual inspection or which detector has, right? For that reason, you've got your red color and green color LEDs. But if this particular detector is installed above the ceiling, if this detector is installed above the ceiling, still, do you think it will be, do you think it is visible?
No, sir.
No, right?
It won't.
So for that reason, to see that response, whether that system is healthy or it has been with the fire, you basically have this response indicator. So the response indicator doesn't give any color. Let's say if there's a fire, then automatically it turns into red in most of the cases. Understand? Or in a few cases, it can turn into, generally it will be in green, and whenever there's a fire, it could turn into red. So that is nothing but your response indicator.
Okay,
Understood?
this
That's
is
an additional component.
basically used inside the false ceiling, right?
Yes,
The
inside the
detects.
false ceiling or in few isolated rooms like server rooms where people do not have access. So what you do though, even though it is below false ceiling, you will draw the cables and you will install that response indicator outside the server room.
Uh,
So this is your response indicator. Fire curve gets written, right? Okay. So that particular one is nothing but your response indicator. Okay. This is response indicator. This is that. Then coming to the next element that you have is after response indicator is your this thing. After response indicator, then anyway, we'll go back to your detectors again. You have one more type which is called as your beam detector. So beam detector is used for very large spaces and when height is also decently high. For example, like warehouses, where, for example, now imagine you have a very huge warehouse. Can you install multiple spot detectors over the slab? It's tough for you, right?
Mm.
because you have 1 lakh square feet, 2 lakh square feet, 6 lakh square feet like that. Whenever you speak about warehouses, so in those areas, having smoke detectors is not at all practically possible. So in those cases, we go for these beam detectors. Okay, so smoke detectors I've explained to you, optical type, but we're gonna have a discussion on beam detectors. Beam detectors means you generally have a transmitter and receiver as two separate components. You have transmitter, you've got receiver. The transmitter and receiver is two separate components. For example, let's say this is your warehouse. Sectional view I'm drawing it. This, let's say, is your warehouse. Generally, you have a sloped roof, alva. Let's say this is your warehouse body. So you have your truss and all, you have it right. You'll have your beams, you have columns, you have got multiple trusses and all. So beneath just the beams, you basically install your transmitter and receiver over here. This is transmitter, let's say, and then you've got the next element, which is your receiver. One is transmitter, one will be a receiver. Then automatically what will happen, the transmitter will continuously transmit the write so that your receiver will receive it. It can even go up to a distance of around, they say around, we can consider up to 100 meters. Between the transmitter and receiver, you can have a distance of 100 meters. Understood? So when you keep it across like this, what will happen? Continuously receiver will receive the signal. This is the transmission signal. Okay. So when transmitter is continuously transmitting, your receiver will receive, everything is fine. But if there's a fire inside the building, don't you think the smoke will basically raise to the top or not because of the density differences? Yes,
Yes.
because
Yes,
smoke is obviously of a lighter volume. So once the smoke enters to the top, automatically it will detect that there's a fire inside the building. So what will happen is basically when you have it, this will basically the smoke particle will stop receiver from receiving. The minute receiver stops receiving, it will show that there's a fire inside the building. Understood? So this type of detector we simply call it as beam detector. Am I clear? You call it as beam detector. Got it?
yes,
Yes.
Then so this is nothing but your beam detector. Then coming to the next element that we have is the working principle. We have something called as ionization. Till now, whatever we had a discussion, what did we use? We use light or IR radiation or any of the radiation that's not visible to naked eye, right? So that is basically your optical type. But one more type is there where we use it in applications where it's very sensitive locations where the fumes could be vapor. I mean, for example, if there's a petrol or anything, if it's burning, your smoke will be it will not be transparent. Sorry, it will not be opaque. It will be transparent. That means clean fuels or storage materials where you'll feel where you'll have a lot of fuel. In those cases, you will if it's something is burning, also you might not get smoke in the first place. You'll just get vapors. Understood? So, but optical type, do you think it will be effective? If the fumes that are output is basically transparent, do you think it is useful for you? I mean, will optical work or not? Hello.
J- just come again, come again.
See, if the smoke is transparent, it is not black or it is not opaque.
Yeah,
So when it is transparent fumes, will optical type of detectors work?
No, sir.
Obviously not, because for optical to work, the smoke should basically reflect the radiation or it should stop the radiation. Right?
correct.
Mm. It should
So
opaque,
for
right?
that reason, we don't use this, we don't use this kind of thing, which is nothing but your, optical type, you can't use it. In the special applications, you have to use something called as ionization type. So how ionization type works is simple. You have again a transmitter. You will not have transmitter. In fact, you have something called as ionization material will be there, which will continuously give alpha radiation. Slightly, I mean, very minor radioactive elements. Okay. So it's quite dangerous. When you buy this particular ones, you should even have a clause of sending back to the manufacturer. So you can't just scrap it on the road because it's quite dangerous. Understood? You have very slight radiation. That's humanly, I mean, you will not be effective. But at the same time, you can't contaminate it as well. Right. So you have, I forgot the material name. I'll get back to you later. So this particular one is nothing but, so it will have certain radioactive material which will continuously emit your alpha radiation. So you have two plates. Imagine you've got two plates inside which you have air, and this particular one will continuously give alpha radiation. So it will continuously give alpha radiation. So because of this alpha radiation, what will happen? Air gets ionized inside this. So when air gets ionized inside this, will it be able to conduct? If air ionizes, will it be a good conductor or bad conductor? Let's say is positive, and this is negative. When air ionizes, will it be a good conductor or bad conductor of electricity?
Good conductor, sir.
Good conductor. So obviously, what will happen continuously? There will be a flow of electricity through this. You agree? So this acts like a conductor. So what will happen? It means continuously the circuit is closed. So when the circuit is closed, it feels that there's no fire. But if fumes or anything enters into this space, this ionization one doesn't have that much power to ionize the air. The alpha radiation doesn't have power to ionize your fumes. Because of that, suddenly this becomes into your instead of a conductor, it will become as a resistance will be offered. So electricity will not flow. The minute electricity stops flowing, automatically it will trigger an alarm saying that there's a fire inside the building. Understood? Yes or no?
Yeah.
Yeah. So this is nothing but your ionization type of food detector. Okay. So optical and this one we have covered. So these are nothing but your smoke detectors. Heat detector I've already told you. You just simply have your a small temperature sensor will be there. So whenever it so you have one more type which is your multi sensor, which is generally your optical sport type plus heat. That means it will have a thermostat as well as it will have this particular it will have a optical setup like small transmitter and couple of receivers. So that is nothing but your multi sensor. So these are the type of detectors that we basically have. So you've got heat detector, smoke detector. In smoke, you have got ionization type and optical type. In optical, again, you have two types. One is spot detector and the other is beam detector. Beam detectors we use in double height areas where you have a large volumes of spaces. You use this one, like theaters, as if really like warehouses. Only those special applications will use these beam detectors. Clear? Sorry,
And
yeah,
this
beam detectors. Rest all
ionization,
we
where
use the
will
spot type only. Sorry, you were asking something?
this ionization type where we will use?
Where you especially place your fuels, very special applications. In fact, in my entire career, I've seen OT only in one of the HCL projects.
Okay.
Bangalore, HCL projects is only location where I've seen where they wanted to store your white fuel. There only you'll go for this kind of detector. Understood? That's just segment. Okay, I guess it's some kind of. Okay. Am I clear?
Yes, sir.
Then coming to the response indicator, also we had a discussion. So whenever your detector is basically be not able to be visible, then you will install your response indicator. Yeah. So this is the main component of the smoke detector. So don't worry about the distances and all. In tomorrow's lecture, we'll work on one particular design. I mean, we'll take a small building, and for that, I'll design the entire fire alarm system. During which I'll explain you the rules and norms. Is it fine?
Yes, sir.
Okay. So this is nothing but your detector. So we have different. We use IS codes for fire alarm system. Don't worry. So this is your detectors and response indicator. The next element that you're going to have is after this detectors is you have next important element is your this one what do you call your in different indicators. Like for example, you have something called as a hooter. So whenever there's a fire, I mean, in your office they might have done fire alarm this thing, right? Mock drill or something. It happens in your office.
Yeah, yeah, got it.
Yeah. So whenever you have it, you hear this kind of blue color light, visible light will be there, and you'll get some weird noise also. Not like
Yes,
ambulance,
sir.
but you'll get some irritating noise. So that
Yes.
will be emitted basically by something called as a hooter. Okay. So it only works on a simple principle. When you give power supply to it, it will start shouting. That's it. Understood. So hooter is of two types. One is a hooter which basically has both the strobe and you have something called as a strobe and flash. So strobe is a hardware which will basically emit this sound. Flash is a component which will basically emit the light. Understood? So I'll just explain you. Hooter, if we open it, it will be visible. So this particular one is your Hooter. Okay, this is one more famous restaurant in US called Hooters. Don't worry about it. Okay, so you have something called as a Hooter. So in this case, you can see kind of a speaker on the top and a flash on the bottom or not.
Yes, sir. Yes.
So this particular one is combination. You can simply call it as your Hooters, but at the same time, when you say with flash means you will get it along with the light. Only strobe means you will get only the speaker part. Clear? All right. So this particular router, you have to provide generally your you have to provide supply voltage. The 24 volts model is also there, or 230 volts model is also there. So you basically provide power supply to this guy, nothing else. Understood? Okay. So
Yeah.
this is nothing but your router. Depending upon the system, which I'm going to explain shortly, we'll do the wiring. So either you can use it using modules or directly from the file alarm also, you can do this particular wiring to this router. It just emits sound. And the rules for this is simple because there's no rule as per NFPA or as per IS code. So distances is not. The basic rule for this particular hooter is whenever the sound is emitted, minimum it needs to be some 80 decibels, number one, or average ambient noise plus 20 decibels it should be. Whichever is highest, that should be your hooter locations. So if you have more doors and all, you have to increase the numbers to make sure that at least anywhere inside the building you have got around 80 decibels sound. Understood?
Yes.
So
Yes.
that is the thing about your hooter. And next element that you have is your MCP, manual call point. So when you install your so what do you mean by this manual call point is, imagine there's a fire inside the building. Okay, but for some reason your detector might not work, or you have seen the fire even before the smoke got accumulated. Don't you think you should be able to tell everyone that there's a fire inside a building or not?
Yes.
So for that reason, you have to go to a hardware called as a MCP manual call point. And I mean, you might have seen this actually near the lifts or near your main exit. You might have seen break glass in case of fire. You might have seen a small box.
Yes, sir.
So that particular hardware is called as manual call point. MCP we call it as. So this manual call point will it will generally have your three this thing. So it will basically have three hardwares. Just a sec. MCP we call it as manual call point. It basically have three pins. in most of the models, I would say. So the three pins are NO. So one pin you have is NO, and other pin that you have is common. Common, and the next one you have is NC. We call it as normally closed circuit. NC. Okay. So generally, this particular one will have three pins. So according to your programming, you will connect any one of any two of these three pins. Understood? In that, you will definitely connect your common, and you will basically connect your either NC or NA according to your program. Don't worry about it. I'll explain you later. So NC means generally this will be in closed state. That means you will have a interconnection between these two elements. So if you connect to a battery means from the other wire you can connect to a lamp. Basically, I mean you can close a circuit. So that means nothing but your NC circuit. Understood? Normally closed circuit. But if someone presses it, the normally closed ones will break. And instead of these two, normally open and common will be in contact with each other. That means initially if the circuit was closed, the circuit will be open. But if you connected NO and common, generally it will be in open state, but whenever there is a fire, it will be in closed state. Understood or not? The circuit wise.
Yes.
Okay. So you will use the signal to trigger that there's a fire inside the building. That means this is used to announce everywhere, even into your PA system, that there's a fire inside the building. So this is just a manual switch kind of system. It's nothing intelligent. Understood? The simple switch, we call it as manual call point. We call it as manual call point. Clear?
Clear.
Then you have one more hardware which is called as door positioning sensor. So what is this door positioning sensor means? This door positioning sensor will have two components in it. I'll just explain you. So there is something called as a reed switch. That is an internal component, but the reed switch sensor, if we do it, then we'll this particular one or your multiple shapes anyway, this is nothing but your reed switch. Understand? It's hardly like $100. Yeah, it's 140 it's showing. But yeah, you have got different kind of models as well. Anyway, this particular one is basically called as a reed switch. If you see, one is a free component and other has a wire in it. You can see it? Yeah.
Yes, sir. Yes, sir.
In that you have internally this component. Don't worry, actually it has shown us $15, but it's hardly worth ₹1. We used to get even 6, 7 pieces that time. But anyway, so this particular component is fused in the plastic mold and all. That's the reason you have a bit higher price. So in this, you've got two components. One is an independent one and other is a fixed one. So whenever you have a door, generally, whenever you have a door, don't you think you have one is your door frame and other one is a flap or not? Which can open and close, right?
Yes, sir.
So basically what do we do is to this flap portion, you will install that magnetic part. To the flat portion, you will install your magnetic one. Understood? To this guy, you'll parallel. You will install this a portion. Understood? So this portion will be connected to your door at some corner. Okay. Similarly, to the frame portion also, you will install this other hardware which is having cables. So this is your magnet. This is your cables. So again, in this also you have two types. One is your NO type and other is NC type. You have it. So generally, if NC type means whenever the magnet, whenever the magnet is there, then it will be in closed state. Open means whenever the magnet is there, it will be in open state. It will be reversed once the magnet touches that. This is simple magnet, nothing else. So when the door is close to this one, don't you think both will touch each other nearly if we place it, if we install it properly or not?
Yes.
If we pull the door flap, automatically this will touch this guy, right? So then what will happen? The open circuit will become closed and the closed circuit will become open, right? So that you will take as a signal that there's a fire inside the building. Understood? So this works on a simple principle of your fire alarm. This works on a simple principle of your, if someone opens the door, you will trigger an alarm. So this will be used for all your emergency doors. That means whenever you're working on projects as per NBC code or as per NFPA codes also, your emergency door should not be locked. Obviously, right? So in case of fire, if you are unable to lock it, don't you think if someone if it is locked, let's say, that time access control might not work if or the key might not turn. Is it okay to have like that? Your only
No, sir.
escape route, you're closing it. So as per norms, you should keep it unlocked. But at the same time, obviously, you don't want to give any unauthorized access. Also, you will be using the door only in case of fire, else you will not use that particular door at all. So if you keep it with your your door positioning sensor, if someone opens, entire building will know that there's a fire inside the building. Yes, sir. So for
Yes.
that reason, for example, you might not use the MCP. You will think about your ass first, and then you will try to go away from the building. Obviously, it's a human psychology, right? So you saw a fire, you started escaping. So once you escape, you will anyway go through the door. So once you go through the door, it will trigger an alarm. As simple as that. Understood? So that is nothing but your door positioning sensor. Clear?
Clear. Yes.
Now, in this, most of them are not intelligent except your detector, right? Because Hooter, it will basically, Hooter, what does it do? It will basically shout if you provide electricity to it. MCP point will will basically turn on the off circuit or it will off the on circuit. Similarly, door position sensor. Now, don't you think you should have some semi-intelligent device to control this power supply or to understand the signal and relate to your fire alarm system or not?
Yes.
So for that reason, you have a hardware called as your modules. You have something called as modules. There are two type of modules. So first module is your this one what do you call monitor module, and other one is called as control module. Control module, and the other is you have relay module. Both control module and relay module works is same, but only thing is one is non-potential device, other is potential device. Okay. So what is the difference between what are the types of these modules are? These are semi-intelligent devices which are programmable, of course. So you have what are these modules is? These modules will basically you have two types. One is monitor, other is control and relay modules. Control module and relay module is same as of now, don't worry. So monitor module, what does it do is it monitors the third-party hardware and it will tell to the system that there's a fire inside the building. Understood? That means it will monitor the third-party hardware. For example, you have MCP, manual call point. Fire alarm will tell to the MCP that there's a fire, or MCP will tell to the fire alarm that there's a fire. What is true?
MCP will tell.
So what should my module do? It should monitor the hardware like your
MCP.
MCP, or it should control the MCP. It should just monitor it, right?
Yes.
For that reason, we call it as monitor module. Understood? Am I clear? Door
Yes.
positioning sensor. You have to use your monitor module. For example, in your fire alarm system, you have a flow switch, if you remember. I've explained to you. At the starting of your branch, you have to install something called as a flow switch.
Mm.
Yes or no?
Yes.
At the main header, when you take your feed main, at that particular point, starting point, you'll install.
Yes,
So
sir.
there also you'll install your monitor module only. Understood?
Mm.
But your hooter, you have to control it. Or fire alarm. Now you tell me, hooter will control the fire alarm or fire alarm should control the hooter? Hello.
Yes, sir.
Who will control fire alarm or hooter? which will control each other. That's what
Yeah.
I see. That means fire alarm will tell the hooter to shoot, or hooter will tell that there's a fire inside the building to your fire alarm system.
Fire alarm will control the.
You control the hooter. So in that case, your third party hardware like hooter needs to be controlled, right? So for
Yes.
that, you use your control module. Understood? For example, whenever there's a fire inside the building, you have to turn off all the AHUs, air handling unit. Then you have to use control module. Am I clear? So according to your requirement, you will use either control module or monitor module. But again, in that you have two types. One is control module and other is relay module also. So difference between one is relay module is a non-potential, like, it's a non-potential device. Control module is potential device. That means it can give in power as well. Same on and off it does it, but only thing is it will do it with some potential one. So according to the application, you will use it. Am I clear or not?
Clear, sir.
If you have that with power supply, you simply call it as control module. If you do not have without any power supply, non-potential contact, you can call it as relay module. Understood?
Yes.
So these are the type of modules that you have. Now, all these components will be connected to a master device, which we call it as fire alarm panel. We call it as fire alarm panel. Okay. So when you see this fire alarm panel, so you have the following things. So whenever you see a fire alarm panel, inside this you have a hardware. So you have something called as a fire alarm panel. Okay. Still small, is it? Okay. So this, imagine this as your fire alarm panel. Okay. So when you have your fire alarm panel, inside the fire alarm panel, you have multiple hardwares. The first and foremost thing that you have is your CPU, which is basically your processing hardware. Okay. So the CPU over the top, most of the models of course, this is a generic model. I've told you this is also like in around like 8 to 10 years back model. Of course, nowadays also you have only things the arrangement could be changed by the OEMs. Instead of vertical, it could be horizontal, but the basic components are going to remain same anyway. Understood? So you have something called as a CPU, which basically all the processing, programming, everything happens. On the top of that, you basically have your display device, where you'll be able to see the display. Yeah, you have something called as CPU. Adjacent to CPU, generally you have something called as your loop cards. You basically have your loop cards. Okay, this is called as your loop cards. LC1, LC2, LC3. See, for example, in this example, I've got three loop cards, 1, 2, and 3. Those are called as loop cards. Understood? Now, what will happen is basically, generally you have different kind. Okay, I forgot to introduce you one more thing. Sorry. So when you consider your fire alarm, there are two types. One is your programmable type of fire alarm panel, and other one is your like forgot the term. Conventional type of fire alarm panel. You have two types of fire alarm panel. One is conventional, and the other one is conventional
Okay.
fire alarm panel, and the other one that you're going to have is programmable fire alarm
Programmable.
panel. Sorry, not programmable, addressable fire alarm panel. You have two types. One is conventional, and other is addressable fire alarm panel. Understood? So, what is the difference between addressable and conventional type is in addressable, it will show you exactly which detector has shown that there's a fire inside the building. Understood? In addressable, it will give which detector, like the first detector, second detector, fifth detector, or 100th detector. It will exactly tell you which detector have responded. But whereas in conventional type, you don't have that option. You'll just know which zone it is. That means you have something called as zones inside your conventional type of fire alarm system. So in that particular one, basically you particularly have a zones. So each zone you will connect to certain number of detectors. For example, let's say your building is small. Okay, your building is small. You have got say these rooms. Now what did you do? This you have connected to one zone, this entire thing you've connected to second zone, and this connected to third zone. So if I know any one of the locations, don't you think it's simple for me to know? Yes or no? I need not go to
Yeah.
each and every detail because hardly I have like 5 or 6 in each zone probably. Understood or not? But whereas for bigger spaces like offices where you have like, hundreds or thousands of detectors, then if you have zones, you can't split it in the first place. You might have to make unlimited number of zones, which is tough. So in those cases, we go for this addressable type of fire alarm system. So in addressable type of fire alarm system, each detector or each module will have addresses to it. That means you have nowadays you have got soft type, but in olden days we used to get a physical address type. So what is that physical address type switch means? Of course, even now you have the older models. I'm not saying no to it. Behind that, you basically have two symbols, two numbers will be there. Okay, two numbers will be there. Here you'll have written 0 to 9 numbers. It will be written 0 to 9 numbers will be written, and along with it, you have a small indicator. You have a small indicator like this with a notch in it. You have a small notch. This notch is basically used for the screwdriver to rotate it. Understood? So here you'll have 0 to 9 numbers. Here also you'll have 0 to 9 numbers. So you can set the number 0, 0, 0, 1, 0, 2. See, this is units place, this is 10th place. So you can give the numbers and you will be able to units place and 10th place, sorry. So you will be able to you will be able to assign till 99 numbers to it. Understood or not?
Yeah.
Of course, later, initially it was 99. Now it has come even with you have got till one side you have units, 10th place you have got up to 20 also. So up to 200 devices also you can create it. Understood? So, I mean, here instead of 0 to 9, you'll have up to 20 numbers or up to 15 numbers like that. So 150 means here you will give 15 and this side you'll give 15 and this side you'll give 1. So it will become 151. Understood? So, like that, you have just two screws using which you will be able to give addresses to it. So, physically, you should ensure that in a particular loop, no two points have same address, else there will be an error code in your fire alarm system. Understood? Now, these detectors, multiple detectors, will be connected through something called as a loop cards. So here, from these ones, you'll basically connect it to the cables. So I'll just draw a line, a polyline instead. So what will happen is you will connect it to multiple hardwares. So I'll just shorten it. So you'll have multiple detectors, you have multiple modules anyway. You have multiple detectors, multiple detectors. Then what will happen? So using this one, you will connect it to, because I showed you in and out loop, if you remember. Yes or no? So each one could be connected to each other or not? You remember? I've shown you the loop in and out to a
Yeah.
detector.
It's
So it
looping.
will be looped. So similarly, you'll have a loop to your module as well. Then, I mean, in this case, basically both positives and negatives will be connected. That's it. Vanilla. So you'll connect it to your detectors. And once your number of devices are covered, there's two ways. One is loop A type and type A and type B type of looping. In type A type of looping, you will not take it back to your fire alarm. Nowadays, it's obsolete. We are not going to use it. You'll just have a resistor at the end. But type B type, you basically have your connection to this particular one. This is type A type of system where you will get back to your fire alarm system again. So that if there's a breakage at one location, even then from here also it is connected, from here also it is connected, somehow it will work. Understood? Am I clear?
Yes.
So nowadays we use, so after looping, again it will come back to your file. That's how we do nowadays. So From the fire alarm system, you have multiple detectors, modules, and all which will be going back. Like that, in each loop, you can have up to it. I mean, depends again on the model, I would say. Generally, the source voltage is 24 volts, but in many models, you will have the source voltage will be 24 volts, but number of devices you can connect. In olden days, it used to be up to 99 devices or 100 devices, but nowadays you can even connect up to 200 devices, is what OEMs are telling. Okay, so 100 to 200 depends depending again on the model. In each loop, you have it. So each one will be connected to a loop card, one on the top, one on the bottom, one on the top, one on the bottom. Like that, you can increase the number of devices by using your loop by having number of loop cards. Understood? Each loop card is capable to handle two loops. Am I clear? So let's say if it's 100 devices, 100 on the top, 100 on the bottom. So totally, how much you have it? 200 for each loop card. So one loop card means, so generally each panel will have I've never seen more than 6 loop cards. So if you have more than that means you have to go for additional panel altogether. But this is sufficient for decent size project in most of the cases. Because one fire alarm panel will have almost 5 to 6 loop cards. Each loop cards can handle two. Let's say how many devices means, let's say 6 loop cards into 2 or 5 loop cards in most of the models into 2 loop cards is totally 10 loops. 10 into, as of told you, nowadays, each loop can even have up to 200 devices. So 2000 devices you can have. I mean, it could be 2000 detectors and one module, or 2000 modules or one detector, or 50%, whatever. The total number of devices are nothing but summation of your number of modules and your detectors. Am I clear? Understood
Yes.
that? So this module will be connecting again to your AHUs, or it could be connected to your fire dampers. It could be connected to your flow switches of your sprinkler system. It could be connected to your door positioning sensor, hooters, modules, all those devices. Are you clear or not?
Clear, sir.
Okay. This is the basic architecture of your fire alarm system.
So
Yeah.
this panel where we will locate?
So this panel will be, I would say it's not mandatory, but generally what we do is we basically place it near the security. In smaller offices, we'll place it in security rooms. It could be a guard room, or it could be reception, near the reception table, or near the reception counter, where generally people will be there and the basic training could be given to anyone. But in bigger projects, we'll install it in BMS rooms, where anyway you
Oh,
have continuous people to monitor the entire building management.
oh,
Understood?
yes, sir.
Yeah. So you have got any queries on this fire alarm system?
Sir,
This FCC room,
I didn't get
uh,
you, sorry.
what a fire command room, sir.
Hmm.